Every contract, all the protocols that run on chain that move billions of dollars, most of it started live as Solidity. Our next speaker, Jakob, works on the compiler itself. And since Solidity just turned 11, he's here to give us a preview of what that future looks like. Let's give it up for Jakob.
Hello, everyone. I'm Jacob. I think I've been to all Dappcons, but this is actually the first time I'm speaking at one, so thank you for finally having me. Today I'm going to talk a little bit about what we're doing at Solidity and what's next. So I wrote my first smart contract in 2015. I don't know if you can read it, but it's the one on some of it is here on the right, and the language looks fairly similar still. Of course, it has changed, but yeah, the tooling back then was almost non-existent. I think we used LS0, if anyone remembers this, to deploy the contracts. It was pretty terrible. Since then, I've done a bunch of things in Ethereum. My whole professional life has been contributing to Ethereum. And now I'm the DevRel at the Argo Collective, and we are, I'm contributor to the Argo Collective, and I'm the DevRel for Solidity. Solidity has been in production for 11 years, and we had the last release was in April. It was the 0835. And as I mentioned, it's maintained and developed by the Argo Collective, and has been since 2025, but the people working on Solidity in the Argo Collective all used to work in the Ethereum Foundation. So it's the same team, but we are now a separate entity that works on Solidity amongst a couple of other projects such as Sourcify, Fei, HEVM, ACT, and FDebug. So, a little bit about what hurts in the language. We recently had our, or not so recently, but we had our results from the developer survey from 25, and the biggest pain points that people point out is the stack too deep, and I did some cross-referencing on some of the numbers, and like the more people self-proclaim to be experts, the more they experience this as a pain point, and have been doing this for some years. So it is definitely something that should be addressed and that we are addressing. And how we do this is currently with, okay, I'll go back. Like, so what is in the 0835 release is, one of them is we had the first comp time built-in. So that's a step in the direction of having more comp time built-ins, and this will also carry over to like future work that we'll be doing on Core Solidity that I'll talk a little bit more about later. Then we have the experimental flag that we introduced, and this experimental flag means that we now have all the experimental features that we can have as part of the language, but they are like you should not use them. They will break, they will change. And the biggest feature that we added under the experimental flag is via SSA CFG, which is what will be solving stack too deep, and it will also eventually speed up compile times. So how does this work? I'm not going to go too much in depth with it. We did another presentation on Monday, my colleague Moritz, where he goes in depth with this, but yeah, as I said, it's the #1 complaint. At its root, you could argue that it's an issue with the EVM and not with the Solidity. I'm not going to go too much into taking sides here, but what we're doing to fix it is the SSA CFG code gen that will do memory spilling, and through that allow to have more items in the stack, or rather, same amount of, but yeah, we do have memory spilling. And we target that for basically out of the Q2. I believe that we have it in the develop branch, but not yet in a release. And then what else is going on is the EIP 8024, which introduces Dappcon, Swapn, and exchange opcodes that basically gives access to more items in the stack. So instead of the 16 that you currently can access, you should have access to something like 272 items. And it is not just proposed for Amsterdam, I believe it is also scheduled for inclusion. But you can only patch your way out of so many things. And as I mentioned, Solidity as a language is 11 years old, and back when it was being designed, maybe 13 years ago, we had no idea, or people had no idea how we were actually going to use Solidity and how we would write smart contracts. So yeah, a lot has changed in the programming language landscape since then, which is why we are also working on what we call Core Solidity, which is a redesigned smart contract language that still uses the same backend as classic Solidity, but probably looks more like what you'd expect a modern smart contract language to look like in 2026. Here's a small example of a classic and a core implementation of a payment handler, where you can see some of the features of Core Solidity versus classic. We have a struct called payment that has different values that can kind of be used to identify a payment type, but there's not really any way to guarantee what a payment struct actually holds. So we have to have all these if statements to figure out which type it is, and then we can do stuff based on that. And for some reason, we also have to return 0 because that's if nothing matches, we have to return 0 because we have to return something. And if we add in a new type, like ESE 1155, there's also nothing in the compiler telling us that now we are not dealing with this case any longer. Whereas in core, we will have ADTs and pattern matching, which makes this specific case quite trivial. We define the 3 different types of payment, and then we pattern match on the type. And if we were to add in then an ERC 1155 payment type, the compiler would warn us everywhere that we are not handling this case, so we would not even be allowed to compile it, and we are forced to handle all cases, which I think is pretty amazing, and I think it will help or solve quite a lot of bugs that you'd otherwise only find after deployment maybe, or later on. So it can save you a lot of time, and it makes it harder to make mistakes, which I think is something we should always strive for, because people will do or will make mistakes, but we should make it as hard as possible for them to make the mistakes. So that is some of the thinking that goes into designing this language. Some of the, this is basically what I said here, that if you miss a specific case, the compiler will tell you and kind of point you in the direction to where to fix it. And this pattern matching also comes at 0 added runtime cost. You could write the same thing in a switch statement in Joule. And basically all wrapper types are erased. So you don't pay anything extra for this. It all is handled during compile time. We also have generics. So right now I think it's 380 different handwritten functions for lock in Forge standard library. And in core, you could handle this with one generic function per arity. So this will also be more elegant, easier to do. And yeah, again, no additional runtime cost for this. It's handled during compile time. Quickly running over some of the other things that we will have in core. The biggest thing that we get a little bit of pushback on is that we are removing inheritance as you know it. So we'll have to do reuse through traits and composition mechanisms. You'll have first-class functions and closures and type inference almost everywhere. And again, we'll have comp time evaluation, as I mentioned, used more frequently in the language. And the first step was in ESE 7201 comp time that I mentioned earlier. And okay, it's a little bit small, but this shows which other core Solidity features that people want. They want better error handling. You get that from the pattern matching. They want better delegate call. That's basically what you could do from the composition. And what powers Core Solidity? Underneath it all, we have a small language called Sail, which allows for some pretty nice things, I would say. So Sail consists of 8 primitives and 1 type. And right now in classic Solidity, we don't have a standard library. So every time we want to have something like ABI in code, we have to add it in the compiler and touch parts of the code base that are quite critical, and even the smallest mistake could have pretty bad consequences. So instead, we are designing Core Solidity to be as small a core language as possible, and then have a standard library on top of it that is separate from the compiler itself, so that people can also define these things, and we can have a community process in place for figuring out what we should have in the standard library. So yeah, it will be easier to read and audit and debug the standard library. You can actually see what's going on instead of reading thousands and thousands of lines of C++ code. And as I mentioned, I think the fact that we can split or separate the language from the compiler also means that we can have 2 different processes, and we can move faster with implementing new features to the language without having to make a new release of the compiler. And you can more or less, basically if you disable the standard library, you just have typed UL left, which I think is quite powerful. And as I said, the language is small, hopefully small enough that it will not be too difficult to formally verify it, and it is something that we are planning on doing as well. So what is the current state of Core Solidity, and what's next? We have recently had quite a lot of contributions. One is that we had a former Solidity team member implement the beacon chain deposit contract, so porting that and writing it in Core Solidity, and from that we had a lot of issues opened and PRs merged that kind of make the language more pleasant to use. I would say that the syntax you've seen so far, it's not something that's set in stone, it's developing and it will be changing. And we also had a multisig implemented in Core Solidity, which is quite cool, because in this code example you can really see some of how the state mesh, like how you can easily represent like the different states of a transaction life cycle, so to speak, in a multisig with the pattern matching and different like kind of a state machine there. Then another external contributor implemented Uniswap v2 pools. And provided us with a bunch of nice feedback in the forum. So that makes me happy, and also the team, of course. But it's always nice to get early feedback from people who use your language and who have opinions on it. We recently also released a blog post on the idea of like pattern matching and how it will work in Core Solidity, because it will be a new concept for normal Solidity developers. They might not know, or at least are not familiar with, using pattern matching in their daily day. We also have recently the first version of the module system that landed, and as I mentioned, the stuff that comes with the experimental flag in the latest release will also carry over to the work that it will be relevant for Core Solidity as well, since we use the same backend, which I think is also an important thing to know. It's not like we're doing everything all over again. We are reusing as much as we can that makes sense, and we do have a pretty battle-tested backend for Solidity, so would definitely make sense to reuse. You can try it out. It's possible to write contracts and compile contracts. Please don't use them for anything production-wise. That would be unwise because there are bugs. But we would love to hear your experiences and any feedback that you might have. And yeah, as I said, try it out. You can do that on, in the Core repository. We are also working on having a playground, like a browser playground, so you don't have to install Haskell and whatnot to actually get it going. Now I mentioned Haskell. That's the language we are currently using for like designing the language, but we will be using a different language for the actual production implementation. We are starting to design the standard library. If you have opinions or ideas or feedback for what should be in there, please reach out. I'd love to hear what you think is important to have in there. We are not going to have a production-ready compiler for this in 2026, but we do hope to have at least something like an alpha version of the production implementation before the end of the year, but no promises. And yeah, all feedback is welcome in the Solidity forum. I think that's all I have today. Please reach out or come find me after the talk if you have any questions or feedback. I would love to hear what your thoughts are on Core Solidity. I think that's all. Thank you for listening.
Thank you very much. Please, do we have any questions from the audience? I think we have time.
One in the middle.
We have one in the middle. Do I see any more hands up?
So you said like stack to zip is pain, right? And why reading external contract storage is not able to read is not a pain? Why we should not have like ext s load opcode? External storage load opcode.
Why we should have it or not have it?
Why we should not have it, because we don't have it, right?
Yeah.
I'm able to read storage only of my contract, but not external one. And if it doesn't expose some view function, right, for specific storage slot I'm interested in, then it's not reachable from the my one, right? So.
But is that not an EVM specific question and not
yeah,
like?
it's EVM opcode.
I'm
curious why we don't have it.
Me too. We don't really have we don't. Like we give input on ideas to change the EVM as long as they would be relevant for the Solidity language. I mean, but
from time to time, someone adds new opcodes to EVM, right?
Yeah, of course they do. But I mean, like I cannot really reply or answer why it's not there because we are not the people making decisions for the EVM, unfortunately.
Okay, cool.
Is there time for one more or? Is there more?
No?
Perfect.
Thank you so much. Let's put our hands together for Jacob.